So we're going to be taking a look at surface area of prisms and cylinders. So a prism is a polyhedron with exactly two congruent and parallel faces. Oh, I put that in the wrong spot. Let me fix that here. Congruent, there we go, and parallel faces. So these faces are what we call bases. And if we're looking at a cylinder, this is very similar to a prism, except instead of the bases being polyhedron, they are circles. Or excuse me, polygons, they are circles. Okay, so it's very important to distinguish the difference between a cylinder and a polyhedron. So the definition of polyhedron is a three-dimensional shape with the faces being polygons. A cylinder, because its bases are circles, does not fit that definition because a circle is not a polygon. So we also want to take a look at just this definition of lateral faces. A lateral face is a face around the prism, faces that are around the prism that are not the bases. So if we looked at kind of a simple drawing here, all right, of this kind of cube-esque thing, if we're kind of highlighting what are the lateral areas, it would be these guys, right? So the ones that we would think are sticking straight up and down, if we were kind of looking at the box, if it was sitting on a desk. All right. So we also have the definition of an altitude or a height, even in a three-dimensional figure. And the definition of that is a perpendicular segment from one base to the other. So oftentimes, if we're looking at a cube or a rectangle, that's just the length of one of our edges. So in a right prism, all lateral faces are going to be rectangles. Oops, missed an N in there. Rectangles. So we can look at a couple different drawings of these. So maybe I'll draw one that's not the traditional prism that we draw. All right, and this is where art skills come in handy. All right, so maybe this is our prism. All right, so if it's a right prism, that means that our edges of our lateral faces intersect our base at 90-degree angles. That's kind of what's going on here. And in this case, our height is just going to be one of our edges of our lateral faces. If we have what's called an oblique prism, this is not a right prism. All right, I'm going to draw a little bit of a simpler prism to demonstrate this. So this is where our prism is a bit slanty. So in this case, our height, we would have to be looking at kind of an altitude. We could think of an altitude, kind of like we did in a non-right triangle. Okay. So when we talk about something called lateral area, that's the area of all of the lateral faces. I'm just going to shorten that as L. The base areas is the area of one base, and we're going to shorten that to B. And we're going to use those in our formulas for the lateral area and the surface area of a specific type of prism or cylinder. So in a prism, we need to find the lateral area in order to find the surface area. So when we look at this, we want to find the surface area, the lateral surface area first, or the lateral area. So the formula for that is going to be the perimeter of your base times your height. So this is for the lateral area. And then we're going to use that to find the total surface area. So the total surface area is all of your lateral faces and both of your bases. So the surface area is equal to the lateral area plus 2 times your base area because you have 2 bases on there. Or perimeter times your height plus 2 times your base area. Okay, so that's for any old prism. So we'll do a little quick example here of a prism. We do need to find some information here because we have to start with our lateral area, which means that we need to find the perimeter of one of our bases. So we're missing a bit of information right there, but luckily it is a right triangle, so we can quickly find that piece of information using the Pythagorean theorem. So go ahead and use your Pythagorean theorem there, and we'd find that the length of that side right there is going to be 5. So we can find the perimeter of our base, so that's 3 plus 4 plus 5, which is 12, and we'd multiply that by our height. Now, because this is a right prism, our height is just the edge of one of our lateral faces there, so times 8, which means our lateral surface area is going to be 96 centimeters squared. All right, now before we find the total surface area, we do need to find the base area. So our base is a triangle, so we're just going to use the formula for the area of a triangle. That's 1/2 times the base of the triangle, which in this case is 3, times the height of the triangle, which is 4. So in a triangle like this, a right triangle like this, doesn't really matter which one's the base, which one's the height. Just make sure you're using the 2 legs and not the hypotenuse. So we do find that our base area is 6 centimeters squared, and now we have all the information we need to find our surface area. So the surface area is the lateral area, 96, plus 2 times our base area, which gives us a total surface area of 108 centimeters squared. All right, so let's look at a cylinder. So the lateral area for a cylinder is 2 pi RH times the radius times the height. So if we think about the lateral area of a cylinder, we kind of want to think about what would happen if we sort of cut a line down the cylinder and rolled that open. And we would have a rectangle where the kind of longer, or one of the sides here, this one would be the height of our cylinder, and then this guy would be the circumference of the circle that we had originally started with. So this would be pi times the diameter of our base circle there. So that's where we're getting that from. 2 pi r is another way of writing that diameter, 2 pi r, and then times our height. So it's really just a kind of a rolled up rectangle. So that's our lateral area. And then to find our surface area, we just want to take the lateral area plus 2 times the base. So we have 2 times pi r squared here, since pi r squared is how we find the area of a circle. So let's find these different pieces. So first off, the lateral area here is 2 times pi times the radius, which in this case is 8, times the height, which is 16. And we do just want to leave this in terms of pi. So we're just going to say that this is 256 pi centimeters squared for our lateral area. Now we need to find our base area because we need that to find our surface area. So our base area is just the area of one of these circular bases here. So that's just pi times our radius 8 squared, or 64 pi centimeters squared. And now we have enough information to find our surface area. So surface area is just our lateral area, 256 pi, plus 2 times our base area, 64 pi. So when we multiply and add that all together, we get a total surface area of 384 pi centimeters squared. So we also want to look at the surface area of pyramids, and cones. So a pyramid is a polyhedron with one face that is a base. Um, so, you can think about the pyramids in Egypt, what they look like. That's a great example of the kind of pyramids we're talking about, although the base can be any polygon. Um, a regular pyramid is a base that is a regular polygon. So that means it's a square or it's a six-sided shape where all of the sides are of the same length. The slant height is going to be something that's very important. This is the length of the height of a regular pyramid's lateral faces. So I'm going to just sketch a little picture of what that means to make that a little bit more clear. So I'm going to draw just a very simple pyramid. I'm going to draw a rectangular or square pyramid, depending on what we think the lengths of these sides are. So here is my little pyramid. And I'm going to highlight one of these lateral faces. I'm going to highlight just this front lateral face, which is a triangle. The slant height is going to be the height of that triangle. So from the vertex down at a perpendicular angle to the edge of our base, okay? So it runs along the outside of the three-dimensional figure, not the inside of the three-dimensional figure, unless it's a very specific type of pyramid. So a cone is very similar to a pyramid, except the base is a circle. So we always kind of have different names for three-dimensional figures where the various parts are not polygons. So anything that has curves, we always give it a separate name. All right, so let's look at these and how we find the various information. So if we're looking at the lateral surface of a pyramid, it's always going to be just the area of these various triangles, right? So we have various triangles that make up the lateral area of this pyramid, okay? So it's going to be 1/2 times the perimeter of the base. So if I'm looking at this pyramid down here, my perimeter of my base is just all the way around that square. And then times the slant height. So the slant height here in example number 1 is this dashed line that runs along that right face. Okay. And then our surface area is just going to be our lateral area plus our base. So we don't say two bases this time like we did before in prisms because we only have one base. So let's go ahead and try to find this information for our pyramid. So we're going to start with our lateral area, which is equal to 1/2 times the perimeter of the base, or 6 times 4, right, which is 24, times our slant height. So for this one, we do have to do a little bit of work to find that slant height because we don't have it. But if we remember, heights are always perpendicular, right? The kind of altitudes, they're always perpendicular to the opposite side, so vertex to the opposite side there, which means we have a very nice right triangle, and we can use Pythagorean. One thing before we start is we do just have to touch up the length of our base because it's going to be 1/2 of that edge there. So it's actually going to be 3. So we're dealing with a triangle with a leg length of 3 and a hypotenuse length of 10. So we're just going to use that Pythagorean theorem, and we're going to find that our slant height is the square root of 91. So just leave it in radical form until we're all done here so that we have an exact answer for our lateral surface area. So don't round it until kind of the end of your problem. So once we calculate that out, we're going to get that our lateral area is approximately 114.47 inches squared. And now we can use that to find our surface area after we find our base area. Okay, so our base here, it's just a square, right? So it's base times height, 6 times 6, which is just our 36 inches squared. So now we have the lateral area and the base area. So finding the surface area is just a matter of adding those two together. So our lateral area plus our base area, which is going to be a total of 150.47 inches squared. So a cone is very similar. And our lateral area here is going to be pi r times a slant height. And the slant height in a cone is the same deal. It's along the outside edge. So if we're looking at this diagram here, the measurement that I just highlighted in blue, that would be our slant height, L. And then our base area is just the area of the circle on the bottom. So it's your regular pi r squared for that formula. So let's go ahead and find some information about this cone. So our lateral area is pi times our radius of our base, which is 4, times our slant height, which again, we need to use Pythagorean theorem. So this time we know both legs, and we need to find the hypotenuse. So that's going to be 2 root 13, excuse me, for our slant height. So we're just going to substitute that in here for a slant height, 2 root 13, so that we can find our lateral area. So pi times 4 times 2 root 13 is approximately 90.62 inches squared. We now want to find our base area. So our base is just a circle. So it's just pi times the radius squared, which in this case is 4. So that means our base area is 16 pi inches squared. And we are going to add them together. And this is one of those situations where, we have one value that's a decimal, so it's fine for your answer to be a decimal instead of in terms of pi. So our surface area here is our 90.62 plus 16 pi, which is going to be 140.88 inches squared. All right. So we're going to look at one more three-dimensional figure, and that's going to be spheres. Okay. So a sphere is simply a round-shaped figure, right? So you want to think about, a tennis ball or a basketball or something like that is a sphere. And then we also have a hemisphere. So a hemisphere is just half a sphere. It just gets a special name. It's half a sphere. So we can see this first figure here is a sphere, and the second figure is a hemisphere. So the formula for the area of or surface area of a sphere is 4 pi r squared, which means the formula for the surface area of a hemisphere is going to be half 4 pi r squared, or 2 pi r squared. Okay, so it's just half of a sphere. So if we have a sphere, all we need to know is the radius of that sphere, and then we can go ahead and find our surface area. So if I'm looking at the sphere, my surface area would equal 4 pi times 3 squared. We're just going to leave it in terms of pi. So that's going to be 36 pi centimeters squared. If I'm looking at the surface area of a hemisphere, we're just going to use half of the sphere formula. So we're going to take 2 times pi times 6, my radius, squared, which is going to be 72 pi centimeters squared.